Now for the Grignard reaction with carbonyl compounds, that can also give you alcohol. So for alkyl, aryl and vinyl halides, they react with magnesium to form the Grignard reagent, RMGX. Now this is a nucleophile, a fantastic nucleophile. You can treat R- as a nucleophile. It's like R with a lone pair of electrons on the carbon, very reactive. Take note, again, there's no free R-, there's only a RMGX, which is like a partial covalent and semi-ionic bond here, so that's why you can't detach it, totally. If you go in from the RMGX, attack the carbon that's electron deficient, break the pi bond up, but now it doesn't come up already, it just stay there as a tetrahedral intermediate, and then the O- picked up the H+ from the acid, you get back the alcohol. So one more time, carbonyl compound, Grignard reagent, alcohol. Now for formaldehyde reactions, formaldehyde is a form of carbonyl compound, it's an aldehyde. Grignard reagent goes in, whoosh whoosh, you get the alcohol. Aldehyde, let's change it, a longer aldehyde, and we change also the identity of the Grignard reagent. We swirl it inside the beaker reaction mixture, boom, alcohol. Ketone, no problem, throw in some Grignard reagent, alcohol. But what you see here is, for the aldehyde reaction with Grignard reagent, you get either primary or a secondary alcohol. In particular, formaldehyde give you primary, any other kinds of aldehyde give you secondary. For ketone, you must have tertiary. You will understand why. Carboxylic acid do not give additional product with Grignard reagent. The reason is because you have OH here, this hydrogen is very labile. Labile means that the H can drop off easily on its own to form H+. So this is the one that the R- equivalent will pick up first to form back my alkane, and you get a salt here. And this makes it very useless because it is a salt, can't do much. But if you throw in an ester, because now the H is absent, so now you spam some Grignard reagent, it will first kick out the RO, and then next step, you get back your carbonyl compound, then the R goes in again, and voila, the alcohol. So from the ester, you spam 2 moles equivalents, 3 of the Grignard reagent, you get a tertiary alcohol. We also use Grignard reactions to make alcohol in the lab, in the industry. So you see, let's say our aim is to make this alcohol here called 2-methyl-pentanetol. What are the ways you can make this? We do something called the retrosynthesis. Retro means going back to the oldies. Now the step before this, what happened? If you notice, if I react pentanetol with this Grignard reagent, see this blue color, methyl goes in, I get back my product. But if I use a symmetrical ketone called the acetone, and I use a longer Grignard reagent here, this black branch, you go in and I get the same thing. You see that? Cut the fragments up. The black one here, or I can make it the incoming group, the blue one could stay. Now let's revise this. When we're trying to convert the alcohol into the alkyl halide, how do we do it? Tertiary alcohol reacts with hydrogen chloride or HBr gas in ether, solvent, via SN1 mechanism through the formation of a carboxyl ion intermediate. You stabilize this by forming a tertiary, if not secondary. This is no good. Tertiary is the best. Then now your nucleophile goes in. Ta-da! Tertiary alkyl halide. For primary and secondary alcohol, they react with SOCl2, PBr3, PCl5. That's how you get the alkyl halide. Over here, the driving force is your SO2 gas entropy. Remember? Delta G equals to delta H minus T delta S. Entropy positive. This is negative. We like this to be negative. Next, for the dehydration of alcohol, they will give alkene. We know that because when we hydrate alkenes, we get alcohol. So now it's just a backward reaction. But to do this, you need acid. Without acid, it won't occur. It works fantastically well for tertiary alcohol. Again, why? Understand, don't just remember. It's because of the mechanism. Step 1. Use an acid first to protonate the oxygen of the alcohol. Then now O takes a plus charge. That means you weaken this bond here because now O wants electron. So once this breaks and cleave, what happens is you get a tertiary carboxylic ion. Notice what I said, tertiary carboxylic ion. Stable. And now the water, which is a weak base, we can pick up the H adjacent to it to form my alkene. Now going back to here, if this is a secondary alcohol, then the reaction is rather slow because if I form a C+, I need more R groups to stabilize it. And that's exactly the reason why this is a major product over that, because this is trisub and this is disub. Zysov rule. Recall? Zysov. Next, we can also convert alcohol into esters. So alcohol reacts with a carboxylic acids to give esters. How do we do it in the lab? You can just do a single step. If a strong acid is used as catalyst, like concentrated S2XO4, battery acid, we know that the reactivity of the carboxylic acid is enhanced by first converting it into a acid chloride, or we can call it acyl chloride. Then I can just do it at RTP. You see? RTP, no need heating. Heating is only done when you have alcohol and carboxylic acid with an acid catalyst. Here, first I convert it into an acid chloride. Very reactive. I just throw a bit of alcohol. Instantly you get the ester. When we oxidize alcohol, primary alcohol give aldehyde first and then carboxylic acid. So can we do a stop at the first oxidation? Yes, we could, but with only a certain kinds of reagent that's a bit milder, that's not too strong. Whereas secondary alcohol, there's only one endpoint. Ketone. You cannot oxidize a ketone. Tertiary alcohol, they do not normally react with most oxidizing agents, so we consider them to be like no reaction. It can't be oxidized. We use something called the Des Martin pyridinane. French guy, so it's Martin, not Martin. Pyridinane, you may think it's a pyridinane, but actually is pronounced per-iodinane. Because you see, in the structure, you have an iodine. This guy here. And iodine here is taking a what oxidation state? Go find out. Very bulky kind of oxidizing agent, but it's mild. So it will convert a primary alcohol to an aldehyde. Stick to this. If we use other reagents like chromium trioxide CrO3, this is what color? Orange color. Or we can call it the Jones reagent. Another name. We will convert directly from the primary alcohol to carboxylic acid. Nowadays people try not to use anything that's with chromium because it's quite toxic, heavy metal poisoning, but there's still people who stick to it because it's quite colorful. So from decan-1-ol, which is a primary alcohol, throw in the Jones reagent, you get decanoic acid. For third, take note, tertiary, butyl cyclohexanol, you do oxidation using dichromate 6, you get the ketone.